Okay, comes to the last question, 2023. This one is the hardest in the DSE history. Okay, so we are given two polynomial, and then it's telling you that when hx is divided by gx, the quotient and the remainder are equal. So it means that when this polynomial divided by this one, the quotient and the remainder are equal. Find the quotient hx is divided by gx. So how we do it? We know that when this one is divided by this one, the quotient and remainder are equal. And you know that when this one divided by this one, the quotient should be something ax plus b, right? So the highest degree of this quotient will only be 1 to make it times together to be power 4, just like what we did in 2020's paper. So first, write out the division algorithm. So although it seems very difficult, but we just do it step by step. We know that this is actually the dividend, and then the quotient and remainder, we just let it. Okay, so now the quotient and remainder are the same. This one is a division algorithm, and then we know that these two actually equal to each other. Now we let d to be a constant. Why we only need one constant this time? As I say, ax plus b, right? Why we don't need two unknowns this time? Because you actually know this 3 here. Why you know that? Because the first term is 3x to the power 4. So here, if you use ax plus d, actually you can directly find out the a will be 3. Why? Because this one times this one should be 3x to the power 4. It should be x power 3 times something 3x. So you can directly find it out. Here we just directly write it, 3x plus d. Okay, so the remainder are the same with the quotient. So here is 3x plus d as well. Okay. So now we have the polynomial in the division algorithm format. We broke it, and then we can have the identity. So we group it in the like term. The coefficient should be equal, right? The coefficient should be equal. When you break this one, you can see here, when you group it, one is minus d, one is plus d. So we don't have the constant term. Actually, you already have the first one, right? And this one, d plus 15 equals to the a here, the coefficient. Okay, the coefficient. So they equal. Can you solve it? Here we have two unknowns, so we cannot solve it yet. So 5d minus 36 equals to negative 16. So we can solve d by this one. And then this one, we negative 12d equals b. So you can solve it because you already have d, right? You already have d. So the c here, it should equal to 0, right? Because we don't have any constant. But now, do we need to solve a? Do we need to solve c? We don't need to, because we only need to solve. The only thing we need to solve is d. Okay, it's d here. Why? Because it's asking the quotient. So when you're doing those questions, keep in mind that always think, what is your direction? What is your goal? Write down your goal. Okay. So the goal is to find the quotient. So a here doesn't matter. B here doesn't matter, C here doesn't matter, the only thing matter is the D, okay? D, we let it into D. So the quotient is 3x plus 4 because D is 4, okay? And then, how many rational roots? So how many roots does this hx equal to 0 have? So we have the whole polynomial here. Do we know any factor? It doesn't provide us any factor. When you don't have a factor, you need to think, what do you have? You have the equation in the division algorithm format, right? You have this format. Actually, this one, can it help you to find the factor? Actually, it cannot. Usually, it cannot. But in this case, in this question, you can find out that because the quotient and the remainder, quotient here and the remainder, they are the same. So, actually, they are common factor. So, very beautiful, this question. You can take out the common factor. After you take out the common factor, what you have here is the factorized term. So, we have finished the factorized by taking out the common factor. This never happened in the Math DSE polynomial history, right? So, it's the first time we have this type of question. Okay, so you take it out, and then we have finished the factorization by this one, not directly telling you the factor, but using the method of taking out the common factor, and then you finish the factorization. Remember that here, every term have x, right? Every term have x, so you need to take out the x. And keep in mind that this is the higher degree is 4, right? So we should have 4 roots. Here we have 2 roots for this one. Here 1, this one is directly this one. And this one here is equal to 0, right? A equals to 0. So if you forgot to take out the x as the common factor, you may miss this one. You may miss this one. X equal to 0, okay? So find out the roots. We have this one, we have this one. Or this one, check with the formula O1. And then you may find infinite decimal. It means unlimited decimal. So we need to do the quadratic formula to find out the exact number. So we have this one. It's not rational because we have the subform, we have the root number. So only 2 rational roots. So make sure you're very familiar with those type of questions. It may change the way of asking. Prepare yourself for that.